Hello, and here's a small update. I spent a while doing mostly the software part, and this involves encoding and decoding. And now I am ready to perform actual testing on the hardware. And I already tested it, and I have some visible progress, so I would like to share a little bit. Practically nothing has changed in the hardware except that I have burned the MOSFET that controls the motor somehow. I had a whole lot of problems with the drive, if you can call it drive, with the mechanism. It's acting up. Probably things are not so great for it. I don't know if I will be able to use it for a long time, but hopefully it will survive until I am done with this. I already wrote some data to it, and I would like to perform a read now. This is the terminal and everything is connected, so let's just hit play and load. Now it says waiting for receiver. Let's see how it goes. Okay, so seems to be doing so, right? So here we have all the text, the plain text that it was able to decode, and some service information like the sector number, file name, and CRC. This is not bad, but there are some problems here. For one, it's not very fast, so I expected it to be able to handle at least 4000 bps using MFM, but in reality 4000 gives just way too many errors. So this is 3500 currently. So okay, so it did read something but had some errors. Let's rewind and try it again. I will also remove the text printing. So let's try reading again. So play, load, and waiting for the receiver. And nothing happens. Now this is another of these problems that I have been mentioning. It's somehow very sensitive to a lot of stuff. I will just reset for now because I don't know what's going on. And sometimes it seems to be sensitive to how exactly the cassette is positioned in the drive itself. So I'll try to rewind and try to hit load again and see what happens. Now it has a few errors, but at least it's seeing things. Maybe a little bit smaller. Okay. Right. So that's about it. There is something about MFM encoding that does not really work as well as expected. Particularly with this cassette. Maybe with this cassette, maybe with this mechanism, maybe with cassettes in general, maybe it just requires the speed to be more stable, for example, and I think it does, but I would like to verify that. I have also been reading about things like precompensation, so that the controller could expect the magnetic material to react with some skew, some delay, and adjust bits in the writing accordingly. So maybe there is that, or maybe MFM just does not really work with tape, and I could use some old-fashioned phase shift keying and see where this goes. Maybe it just gives a little bit more headroom for experimentation. And perhaps just another attempt just to see how it goes. Let's insert the tape. It's not like it's not fixed. it seems to be alright, but you can definitely move it around a little bit. Also, the heads, they have these tiny horns, and that theoretically at least should keep the tape straight. But I don't know if any of this really works. So anyway, I reinserted the tape, and let's hit play. Nothing happens. Why? Let's hit play and load. So here it rolls. The first sector is not okay, and actually nothing is okay. So nothing has changed. I have just removed and inserted the tape again. Let's wiggle it a little bit. There is something. Wiggle it again. Shows something, but doesn't really play, doesn't really read correctly. So I can adjust it a little bit like so. In a proper cassette deck, the tape would be probably held with the help of the cover. I don't know. Here there is this little thing, but it does nothing. So anyway, the same tape rewound and reinserted, and I cannot read anything. So I will again just reset the controller and try again. Rewind. And hit play and load. And hopefully this time it will be better. Yes, so nothing has changed. I did not touch the tape, so there is a little bit of mystery to it. Maybe it's actually a problem with the signal, maybe it's something in the software, but I think as long as I don't touch the tape, I can read it as many times as I want. So I suspect that the problem is something about the alignment. And for example, if this would be a 4-track head, the problem probably will become a real nightmare to handle. Speaking of nightmares, this has been giving me a lot of headache, and I had to replace the transistor here, the MOSFET. It's currently under the board, and I have decided that I don't really want to continue doing things like that, and I will probably keep it on the breadboard for the time being, and when I have something decisive, I'll move on to PCBs. So anyway, let's rewind it. A few words about what we are actually seeing here. It says sector number, file name, block number, CRC, and sometimes it says unrecoverable error, although in this case the error kind of seems to be alright. It uses libcorrect, which implements read Solomon code for error correction, and this puts some constraints on how the blocks are organized. So for each 255 bytes we get only 2 and 23 bytes of payload, and naturally it makes sense to arrange this payload in a way that would also have some useful information to identify where we are on tape and to help decode things or maybe restore partially lost information. So there are naturally sectors, and each sector contains a track number, sector number, a short file name, a block number within the file, the actual data, which is 200 bytes, CRC is 16, and just one reserved byte. To read everything, there is a basic implementation of a delay locked loop, which attempts to track little phase errors that are inevitable during reading, and it implements a PI controller which does a reasonably good job at compensating short-term and long-term speed deviations. But it's not ideal, obviously, because I am still getting plenty of errors. I don't know if they are purely mechanical and if they can be compensated using something like this. It seems to be, so this is like just a PI regulator. Here we get the frequency tuning word, update phase accumulator, and sample the bit when it overruns. So that's all there is. And this is the callback that actually updates the bytes, decodes MFM and updates the bytes. And when the sector is complete, it asks to resync, to wait for another sync word A1, MFM A1, and updates the sector information. And in the end, it just says like, hello, I'm done. This is done on the second core because it was much easier to do loopback testing like that. The 0th core sends, transmits, and the first core receives, and they do it independently. During writing, it just puts a short leader, which is basically just a beep, MFM sync word, and then encoded sector data. Right, so that's all there is about the software for now. So thank you for watching. Goodbye.